Okay, class. So we are going to do our first hour for this in this video. So it will be about chapter 8 hydroxy compound. So first question, draw the structural formula. Okay, so the structure formula is quite straightforward. So please check your answer. For A, 2,2-dimethyl cyclohexanol. For B, 3-isopropyl, 5-methyl, and 1-heptanol. For C, you have a 2-ethyl cyclopentanol. Okay, for second questions, arrange the following compounds in increasing order of boiling point. Okay, so here is the explanation for you, and we label as A, B, C, D to make it easier for your explanation. Okay, so if you look at the structures over here, we have N-butane, which is a straight change butane, 1-propanol, followed by 1,2-ethane diol, then 1,3-propane-diol. C and D has higher boiling point due to the presence of 2 OH group, okay, and they can form more hydrogen bonds. And this is because hydrogen bonding is stronger than van der Waals forces. Structure D has the highest boiling point because it has the biggest molecular size and therefore stronger van der Waals forces compared to C. And last one, we explain between A and B. Says we want to explain about A. A has the lowest boiling point because there is no hydrogen bonding or no OH group, and it only has weak van der Waals forces. For your part B, you can expand out the structure PQR, and you can see all these three structures has only one OH group. Okay, so the hydrogen bonding is the same, but in terms of molecular size, they are different. So in general, the bigger the molecular size, stronger the van der Waals forces, and higher the boiling point. So in this case, structure R has the highest boiling point because it has the biggest molecular size and therefore stronger hydrogen bonding. Question number 3 is about the arrangement of solubility in water, okay, in decreasing order. Okay, so for solubility, we look at two factors. First factor, is there any presence of OH group? If yes, how many of them? Okay, if you have more OH group, that means you can form more hydrogen bonding. Therefore, solubility will increase. Second, we look at the molecular size. Okay, if you have a bigger molecular size, so we will talk about the hydrophobic area. Okay, bigger the molecular size, bigger the hydrophobic area, therefore solubility will decrease. So according to the questions number 1 here for part C here, ethanol and 1-pentanol and 1-hexanol. So the factors related to these questions is the molecular size. So in the increasing order, ethanol, structure K, has the highest solubility in water. And it decreases down to 1-hexanol. So in our explanation, the bigger the molecular size, the bigger the hydrophobic area, the lower the solubility in water. So M has the lowest solubility because it has the biggest molecular size and the biggest hydrophobic area. Second part of the questions, we have 1,2-ethane diol, 1-hexanol, and hexane. Okay, so in this example, we are using the factors of OH group, the presence of OH group. Okay, as you can see, 1,2-ethane diol have 2 OH group, so it can form more hydrogen bonding with water. 1-hexanol has 1 OH group, and hexane has no OH group, so cannot form hydrogen bonding. So here is the explanation. X is the most soluble because the presence of 2 OH group can form more hydrogen bonding with water, okay, compared to hexanol, which has only 1 OH group. Hexane, which is a structure Z, does not have any OH group. Okay, therefore it cannot form any hydrogen bonding with water, and therefore it is insoluble. Alright, so for question number 4, it's about the preparations for alcohol. So remember, we have 4 steps to prepare our alcohol. It can be either fermentations of glucose to form ethanol, hydrations of alkene, hydrolysis of alkyl halide, or the reactions between Grignard reagent with carbonyl followed by hydrolysis to produce primary, secondary, or tertiary alcohol. Okay, so we use the questions as an examples and revise back what we have learned before this. So for A, fermentations of glucose to form ethanol. Please bear in mind that the fermentations process can only produce ethanol. So we use the formula for glucose C6H12O6 in the presence of yeast to produce 2 molecules of ethanol and carbon dioxide. For B, hydrations of 1-methylcyclopentane. Okay, so the structures of your 1-methylcyclopentane undergo hydration, and we have H2O in acidic medium H+. Okay, so in these reactions, we use the Markovnikov rules. So the hydrogens were entering the carbon, which have more hydrogen atom, and then OH were entering this carbon. Okay, so here is your product following Markovnikov rules. For C, hydrolysis of 2-chloropropane. So we substitute the chlorine with the OH to produce our alcohol here. So revise back what we have learned before this, the class of haloalkane, the strength of nucleophile, and this one we can actually link back to the revisions between SN1 and SN2 mechanism. Okay, so for this you can check back chapter 7. And last one, we have the reactions between Grignard reagent. So this one we will look at question 5. We start off with our structures D. Okay, so focusing on this one, yeah? Okay, from your structures D, when it react with magnesium in the presence of dry ether to produce our Grignard reagent. So focusing on this one, we have our magnesium insert between bromine and carbon. So the starting material D is our haloalkane. Okay, so magnesium entering between carbon and halogen. So we are creating a delta positive magnesium and delta negative your nucleophilic carbon. Okay, and the next one is the reactions between our Grignard reagent with methanol. Okay, so we learn about how to do the delta negative carbon, delta positive magnesium, and in our methanol, there is a delta negative oxygen and the electrophilic carbon. So the new carbon-carbon bonds will form between these two carbon. Okay, so our first step, reaction between these two reactants in the presence of ether solvent, and followed by hydrolysis process to give us primary alcohol. Remember, Grignard reagents with methanol, okay, to produce our primary alcohol. So in this case, we are producing, new bonding is formed between the carbon here. So when you make a new bonding, we push away the double bond. So it becomes C single bond O. Okay, so we have a CH2OH for this one. So the final product for your A is a primary alcohol after the hydrolysis process. For your B, Grignard reagent react with reagent B and produce the product here. So if you look at the one highlighted in pink, so this one is come from our Grignard reagent. Okay, and for this part, it's come from our carbonyl compound. Okay, so let's just do the classification for this alcohol. Okay, we have a secondary alcohol here. So remember, Grignard reagents with aldehyde. Okay, beside methanol, we will get our product secondary alcohol. Okay, so in this case, our structures B, it will be an aldehyde containing 2 carbon. That is our ethanol. Okay, and followed by hydrolysis process. So reagent B, reagent conditions is both step 1 and step 2. For our last structure C here, okay, Grignard reagents, again, we have a delta negative carbon and a delta positive magnesium. So in our ketone, okay, this is our propanol. So here is our electrophilic carbon. Okay, so new bondings will form between these two carbon. So when you attack on this new electrophilic carbon, you push away your double bond to become single bond. Okay, so here, a new bonding form between the Grignard reagent and our ketone. So CCH3, CH3. The C double bond O will break into C single bond O, and after hydrolysis, it will get a tertiary alcohol. So in question number 6, outline the synthesis of 2-methyl-2-propanone for chloromethane. So here is the structure of your 2-methyl-2-propanone, and here is the structures of chloromethane. Okay, so let's check about this final product. We have our CH3, which represent the structures of chloromethane here. Okay, but we know that in order to produce our tertiary alcohol, it must go from Grignard reagent, okay, together with ketone, okay, followed by hydrolysis in our second steps to produce a tertiary alcohol. Okay, so here is slogan that you need to remember. So our haloalkane, this is our haloalkane here. So before we produce our final product, you must have the Grignard reagent. So first of all, think about how to convert between haloalkane into our Grignard reagent. Okay, you must undergo the reactions with magnesium in dry ether solvent to get your CH3 MgCl. So in this case, we have our nucleophilic carbon and this carbon. Okay, so a new bonding is formed between the carbon here. So you can see that highlighted in blue color, okay, is our Grignard reagent. Okay, and the one that highlighted in green color is actually come from our carbonyl compound. Okay, so it represents like this: CH3, COH, which come from our C double bond O. Okay, so this is our ketone compound. So new bonding is formed between these two carbon. Okay, the nucleophilic carbon and the electrophilic carbon in our ketone. And of course, we will complete the reactions followed by hydrolysis. Okay, so from haloalkane, produce Grignard reagent. Grignard reagent react with ketone followed by hydrolysis to get our tertiary alcohol.